Welcome to Balvigan Bharti with Avilas Sarkar. Now we are moving on the problem solving on the topic of your Bernoulli's theorem or Bernoulli's equation. There we have seen, so whenever there is a fluid that is ideal fluid, which is non-viscous, non-incompressible, means incompressible and irrotational. That means a complete ideal fluid having these three character mandatory. This fluid, if it is flowing through a duct or a flow path, it is having property to maintain its total energy, means energy at any point is being conserved, and at the same time it also follows the continuity equation. On that basis we are solving problem, and we have solved two problems. Now further we move on to the third problem. We'll show a few of the problems which may be of different kind, so that is need to be shown. Water falls from a tap with AO, means the cross section from where the water leaving the tap is AO, the point where it is leaving, 4 meters square, and A, that means where it is dropping. Okay, the cross section is reduced to 1 meter square, and the height through which this falls to become this cross section is 2 meter. Then find velocity V, if it is there at this point, is how much. Okay, so now let me draw it schematically so that we can understand the situation. Now as we can see that any tap, if I draw it properly, any tap which is having some this could be the handle of the valve, and if spindle, we can see there is a disc inside that is opening. The water is flowing through it, and there where, let's say, this is flowing through this, and after some time later, due to the natural tendency of the water flowing through this, okay, this is being reduced, and let's say this is our reference frame, and this point is 0, this point be 1 where it is dropping, let's say this point. So the cross section here A is equal to 1 meter square, and there at point cross section A0, this is, let's say, A is equal to 4 meters square. Okay, what else? The height of it is 2 meter, and the velocity V here is how much, that I need to find. The water is flowing at there, and this is the case. Okay, so velocity V, let's say this is V0, that is unknown, and if I consider just when it is leaving there, the pressure energy P1, if I say, that is how much, this is flowing through this. So for this stream, the pressure energy is, we can say, P0 is the pressure energy here, because that is open to atmosphere, so that their pressure has to be equal to the pressure because this pressure is equal to this pressure, so their pressure is equal to P0, that means P atmospheric. Basically this is open to the atmosphere, so pressure at this mouth has to be equal to atmospheric. Okay, and now pressure here we don't know, that maybe we can say P at this point. Okay, so now this, if I assume using first solution, what we will do, using continuity equation, because this is a streamline flow, so that means the cross section A, here cross section is A0, let's say V0 is your velocity here, and where it is ending as a point of concern is A1, so and V1, let's say. So A0 cross section is 4, V0 we don't know, A1 is 1, and V you have to find, so we will keep it V. So what is the relation between V0 and V? V0 upon V, that is equal to 1 by 4, or let's say V in terms of V0 is equal to 4 times of V0. This could be our first equation. So we will put this only into consideration. So we will find what we have find is equal to 4 into V0. Okay, fine. The second equation will be pressure energy at P0. This we are taking as P0 plus half rho into half rho V square is this V0 square plus what else, rho GH, rho G, and H is equal to, here if I consider what is your height, H1, if I say this is the height and their height will be, so H is equal to H0, let's say. Let me write the first equation, then we will put the value. So here is equal to P1 plus half rho V1 square plus rho G H1. Now this H1 is this side, so from the reference frame that value is equal to 0, so this will be 0. What is V1 we know, what is H0, 2 meter we know, V0 find, P is atmospheric pressure. What is P1 here? If P is atmospheric pressure, P1 is equal to how much? P1 usually here is equal to atmospheric pressure again. The pressure here is also atmospheric for this water. So P1 also atmospheric, P0 is also atmospheric. You may think that why not P1 is P0 plus H rho G, because that is the potential energy here, that is also being considered here. P0 plus, because we are equalizing the energy, not the pressure. So equalizing energy means whatever energy is there, it is atmospheric plus the potential energy. That potential energy is converted into the kinetic energy, sacrificing what? P0 will be P0, sacrificing this part, that is converted into kinetic energy. Okay, understand? So sacrificing what energy? This energy minus this energy, and your pressure energy here, if I say pressure energy particularly, not that potential energy. Pressure energy, the energy, it is caused due to the stream itself, not its position. Understand that? So here you have to understand, here pressure also equal to atmospheric pressure, because that is the pressure of the stream, that is against which it is working. So the pressure energy, the energy which is causing it to flow. So the pressure energy here, it is equal to the pressure energy of atmosphere. This is also pressure energy, but the energy that is being converted, that is the potential energy. If I say this part is the potential energy is high, kinetic energy is the less. Here your potential energy is being reduced, kinetic energy is increasing. Understand? So P1 also the atmospheric pressure, So in In other case, the theory where we have seen this part, okay, it is flowing through some part, we have taken what, the height. So this is the potential energy, and the pressure energy, as it is being a part of the path, there we have taken P1 and P2. But this P1 and P2, if it is in atmospheric, it is a closed part, so that pressure energy being created to flow it. So this is not the same condition here. It is flowing through some conduit. Now if a water is being projected outside, now it is under the effect of the atmospheric. So what pressure it is working? Atmospheric. Here also it is atmospheric. The pressure energy, the pressure energy is the energy, that is the energy is, it is affecting this flow, external pressure energy. But this case, the pressure energy is being created by a prime mover or some static head. That is due, the difference is coming here. There is no additionally, so static head already is there, the tap is falling, some static energy there, from there it has dropped to this. After reaching there, he is attaining some pressure energy from the static head. It is, once it is released, now the pressure energy here, it is equivalent to, so here if it is atmospheric, if it is open to the atmosphere, so pressure here it will be atmospheric. So P2 we will consider, so same thing, when it is released it is atmospheric. Here also there is no boundary, so atmospheric. So you have to understand this, which we have to take during the solution. So for any such case where the flow is not flowing through the conduit or any duct, closed duct, if it is a atmospheric flow, that means when you are ejecting some water through a fire hose, the tip of the hose, when it is reaching, from there it is releasing, it is coming under the atmospheric pressure. The pressure here is also atmospheric, here also atmospheric. Understand? So this pressure energy, both are same, so we can nullify, as because both are atmospheric pressure. So what else is remaining? Half rho, as because this is water, so rho you know, V0, we'll keep it V0 square is equal to plus rho G H0 is the 2 meter into 2 is equal to how much? Half into rho into V1 square. So V1 square is V square and remaining is out of the scene. So this you can rub. Okay, now here come this equation to be used. So 2 rho G, that is equal to half rho, if we take common, this is V square minus V0 square. Now we'll put the value of this half. So this half can be adjusted there. 4 rho will be cancelled out. 4G is equal to V square, that means 4, so that means is equal to 16 V0 square minus V0 square, so that means 15 V0 square. So V0 square is equal to 4G by 15. Understood? So V0 is equal to under root of this. Okay, so I will take it there itself. So what is V? So V, you know, 4 times of this. So V is equal to 4 times of under root of 4, that means 2. So this will come as 8 and this will be G by 15. So this will be your answer here. What is the velocity? It is 8 times of G. So now if I can put, G is a known one, as because everything in SI, so we can put G approximately 10. So this is 10 upon 15, that is equal to 8 root 2 by 5253 root 2 by 3. Now you can convert this also into some, because this is 1.4 if it is needed. If it is needed a particular 1.732 root 3. So this you can further calculate, or otherwise 8 under root by 3 is also a correct answer for you. Okay, fine. We will move to the next problem. So one thing it is the what is the take from this problem is whenever the flow is atmospheric, it is happening in atmospheric without any concrete boundary or any fixed boundary. It is moving through the air. So from the starting of the flow to the end of the flow, that is coming under atmospheric pressure. So pressure energy will be nullified there. Okay. So moving to next, the problem number 4. Again, it is a problem of tap. Let me see what difference is there. Water from a tap emerges vertically downwards with an initial speed of 1 meter per second. The cross-sectional area of the tap is 10 to the power minus 4 meter square. Assume that the pressure is constant throughout, the stream of water, and that the flow is steady. The cross-section area of the stream (0.15 meter below the tap is how much? Assuming G is equal to 10 meter per second square. Fine. So if I draw the same tap, okay, to make it little bit small. Now this is the handle, you can understand this is handle. Now this is the valve inside. Okay, this is the disc, and water is flowing. This is flowing. It will make some reduction in cross section. Let be the reference frame, and this is the water. This is the end of the tap. Okay, from there it is flowing. Okay, fine. So water from a tap emerges vertically downward with an initial speed of this. Their speed, if you say the V0 is 1 meter per second. Let me write all the details. the cross section area of the tap is the cross section area of the trap, that means A0 is equal to 10 to the power minus 4 meters square. Assume that the pressure is constant throughout the stream. So there already it has said that P0 and P1 throughout the same is same. So that means P0 and P1 are same. There is no ambiguity. You need not to think about all the pressure, because even though it is not there, you can think of this, because once it is coming to contact with the contact of the air, the pressure will not vary, because it is in the atmospheric pressure, working in the atmospheric pressure. So there also there is being released, so the constant throughout the stream of water, and that the flow is steady. So that flow, whatever is flowing through the air, it is steady. Okay, that means streamline flow. The cross section area of the stream 0.5. So where it is height is where we have to find the cross section. Let us take the reference there itself. So I am just talking about this reference where the height is ending, because we have to find the cross section here. So we can say this is cross section A1. So this is just kind of similar problem. So what we have did, we have used the continuity equation, because this is steady flow, we will use it. So from there, A0 is 10 to the power minus 4. What is V0 is equal to 1. And as it is all in SI unit, you need not to worry. So whatever the cross section you will get here, let's say this is A1 and velocity V. The both are unknown. Velocity is also unknown, but the height is known. So that is there. And apart from that, if I say if I use the free falling body, for free floating body, if I use that formula instead of that energy conservation, that also a energy conservation if I use the formula of free flowing body. So what is the free flowing body for this? Because there is no force is acting, only by gravity it is coming. So in that case, the distance h is equal to or v square, you can say. The velocity here, v velocity you have assumed is v1 square is equal to v0 square, that is the initial velocity, plus 2g and h. This can be used because this is also a part of a free flowing body. So the velocity here of that free flowing body, that's mass, sum of the mass, okay, is equal to v1 square at this point. That means final velocity. What are you using? The final velocity is equal to u square plus 2g h against the gravity, because this is with the gravity, that is will be plus. So v1 square is equal to v0 square. So v0 square is equal to 1. Okay, 1 square means 1. 2, g means 10, and h is equal to 0.15, 0.15. Okay. This you will get by using the formula of the energy conservation. How? Let me show it again. So this is P0 plus half rho V1 square, that means V0 square, plus rho G H, okay, H0 is equal to, because pressure is same, so I am taking P, this is also P0, because P0 and P1 same, it must be P1, but instead of that I am putting P0, okay, plus half rho V1 square plus rho G H1, okay. Now if I arrange this here minus, we are deducting, so arrange this, what I will get the pressure, I will move in one side, this rho G, what we will get, H0 minus H1, okay. Okay, let's say this from any reference frame, I am taking height of this point is H0. Instead of this reference, you just think some other reference I am taking, from there that it is H1. Okay, if it is so, and other other velocity part I will keep on the other side. It is v1 square minus v0 square, isn't it? Now rho cancelled out. Okay. Now h0 minus h1 is the, if I take this reference, this is h1, this is h0. So but difference of this will be only h0 minus h1 is this much height. Okay. So this is what? This is actually, if you can take, say this is h0 minus h1 is equal to this height h. So you can denote this is h. So this is also bh. So g into h is equal to half into v, the final velocity, v minus u square. We can take like this. So this which is coming what? V square minus u square is equal to, this 2 will go there, 2gh. Now see, this is the same formula is coming. If you even use the energy conservation, so I am straightway using that formula here itself. This is nothing but the same formula. What is that? V1 square is equal to V0 square. This is it is the same as we have learned in projectile in case of fluid, that kinematics. In kinematics we have learned one more subject, that is the projectile. Projectile for free flowing body, free falling body, we have seen when the body is coming from some height against with the gravity, that is the formula. So this is the case. Now v1 square is equal to v0 square, that is equal to 1 here plus 2g into h. Okay, now this is equal to how much? 2 into 20, this is 30, 2 into 15, 30. So this will be 0.3 into 10, that will be 3. So 1 plus 3 is equal to 4. So v1 is equal to 2. Fine. As v1 is equal to 2, what will be the area then? If I use this formula, 10 to the 4 by v1 will be there 2. So that means 0.5 into 10 to the power 4. So if I now put it like that, if it is needed, there is no need, but if I put by removing the decimal, it will become 10 to the power 5. And what is that area? This is meter square, isn't it? Because other one is 10 to the 4 meter square. So area here will be 5 into 10 to the 5 meter square. Understood? So I'll move on to the next problem in next episode, because problem is bit lengthy, as because it is need to be discussed and analyzed properly. Otherwise there is no need of or use of this kind of discussion. So I am taking little bit more time so that problem can be properly understood. So this will help you solve more different kind of problem along with the problem, because these problems are conceptual problems. You will get some concept out of it that is not even covered in theory part. So every problem is have their specific you can say specific values. So just concentrate on each and every problem, you will get some different concept every time. So thank you for now. In next video I'll move on to few more problems, then after I will move on to the further theories. Okay, so thank you for now.